Good morning to everyone, dear authors and invited guests. Welcome to the technical session 2AF. My name is Siddhi Audi and I'll be the moderator for today's session. So if there are any technical issues or any queries regarding the Zoom meet, you can text me in the chat box. On the behalf of Global Knowledge Research Foundation, I'll be the moderator. It is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London on 19th and 20th Feb, and the virtual event will be held today and tomorrow, 21st and 22nd Feb 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation, and 3 minutes will be given for the questions and answers. So in total, you have 15 minutes, 12 for the presentation and 3 for questions and answers. After 10 minutes, I will raise a gentle reminder for you so that you know you'll get a notification from me that you have to wrap up your presentation. There is another request to all the participants that you all stay connected till the closing remarks. If you have any query or update, you can write it to me. Just before we get started, I would like to introduce you all to the chair for today's session. Just a second, this issue with my. So the first chair for today's session uh, are Dr. Kalpesh Popat. So Dr. Kalpesh Popat sir is working as associate professor at Mawadi University, Rajkot, Gujarat, India. He has completed his doctorate from Gujarat Technological University in computer science field. He is having 20 plus years of teaching experience. He has published 30 plus research papers in international conferences and international journals. His area of research includes mobile computing, IoT, AI/ML, and cybersecurity. And next, I would like to introduce the second chair. My presentation is, let me share the screen again. Just let me know if my screen is not visible. So the next chair for today's session are Dr. Ezekiel Uzor Okike, and he has received the BSS Computer Science Masters of Information Science and PhD from University of Ibadan, Nigeria in 1992, 1995, and 2007 respectively. He is currently a senior lecturer and the cluster chair of Information System Clusters, Department of Computer Science, University of Boston. His research interest areas are software quality models and architecture, software measurements, information systems, software engineering, machine learning, information security slash cyber security, and e-systems. Now, I would like these were the session chairs for today's session. Now, I would like to start with the presentations and the papers. So, the first presenter is for today's session is Temleng Malinzida ma'am. I would request ma'am, please, to start with your presentation. And their topic is comparative analysis of small cells efficiency between 4G and 5G. Ma'am, are you present in the meeting? Can you please let us know?
Yes, I'm here. Can you hear me? Hello?
Yes, we can hear you. I'm so sorry if I pronounced your name incorrectly. It's the accent. I'm so sorry for that.
Please share my screen.
Yes, I'll stop sharing.
Okay. Thank you so much for the opportunity. My name is Temhlanga Malinsisa, from University of Mpumalanga, and I'll be presenting a study that I've done with my honors qualification with University of Mpumalanga, and the study, and I think it's worth mentioning to say that this is my first presentation, so I'm so delighted to be part of this group. And yeah, and also I've explored using generative AI to do my presentation. So you'll help me to evaluate if generative AI is doing a good job in helping or assisting us in coming up with our presentations. So my topic of study was about it was a comparative analysis of small cells efficiency in 4G and 5G. And we were analyzing the impact of small cells efficiency on wireless networks. So to start with, I'll just share a bit on the gap that we identified from literature. It has been noted that there's an increased demand for high speeds connections and a rising demand for high quality services and faster data rates. And these needs to be run through sustainable power usage as well for the wireless devices. So in trying to cover the gap, we have identified that small cells are playing a crucial role in that. And some of the questions that we were trying to answer for in our research was that, are small cells more effective when deployed in 5G than in 4G? And it has been noted in literature that small cells are promising to give us 100%, 1,000 gain in supporting throughput. So the objectives of the study were to compare the throughput supported by both 4G and 5G in small cells. And also we wanted to compare the offloading rates between the small cells base station and also macro cells base station. So I'll further elaborate a bit on what we found in literature about this subject. Mobile data, with regards to mobile data offloading and network capacity, which is sometimes referred to as throughput, the use of small cells for offloading and network capacity improvement have been suggested as the way to be used. And traffic offloading through small cells has been considered as a promising approach to accommodate this high demand or the tremendous traffic that is foreseen in the heterogeneous cellular networks. This includes the network capacity improvements as one important aspect that small base cells has to achieve. So the matrix that we found in literature that are used to evaluate the efficiency of small cells were the spectral efficiency as well as energy efficiency. So spectral efficiency, mobile data offloading technologies and their potential impact on wireless access networks were mainly our focus in the study. So from the picture on my right, we can identify that in some of the matrices that are used in literature, we focus mainly on the top two, and we combined these two in our study. So the first one, which is spectral efficiency, includes the bandwidth, which is part of our calculation that we used, and also the power, which is the power transmitted in the mobile devices and the signal. And we use Shannon's theorem to calculate the bandwidth and also the spectrum, the signal and interference and noise ratio. I will further then deliberate more on the research methodology, which comes in 3 formats. We have firstly, we can look at the research design, where we worked on the conceptual design of the model. And we first defined the system, how it was going to look like, and then we designed the model that we used. In the system model, we then adopted Mustafa's design of a 2-tier heterogeneous network. And this 2-tier heterogeneous network was composed of one small base cell station that was located within one macro cell base station. So this was repeated in 4 scenarios, 2 for 5G and 2 for 4G. So the first scenario for 5G included, it has in it one macro base station, like I said, and a small cell base station. And these two had an interval of 50 meters apart. And then in the second scenario, the small cell base station and the macro cell base station were 450 meters apart. These 2 scenarios were then replicated for a 4G scenario, since it was done in the 5G scenario. And then in the system procedure, we used Excel to simulate our calculations, simply because of our financial constraints. Since I mentioned in the beginning that I was doing my honors level, so projects to run budgets to run honors projects usually are not sufficient for us to buy certain packages like MATLAB or MATLib for Python. So we used Excel, which gives us similar results as the other packages that I've just mentioned. I will then further just show you the parameters that were used to calculate using our Shannon theorem that we used. Basically for the 5G micro base cell and also the 4G micro base cell. For the small base station for 5G and 4G, we use similar calculations. So like I have mentioned now, that the interdistances were 50 meters for the closest small cells to the micro base cell and 450 meters the furthest small cell from the micro base station. And then we also calculated the path loss, and we used the bandwidth and base station power and thermal noise power as shown in the table, which was adopted from the ITU and 3GPP specifications. I will further now present to you the simulation results that we got from our model or from our simulations. So for the first, to show the throughput comparison between 5G and 4G networks, in the first graph, we can see that 5G has got a higher throughput as compared to the 4G networks. And this supports our main objective that we started with from the beginning. And we can see that this is the distance that was covered by the user equipment, which was randomly picked between 0.3 meters and 10 meters from the small cell base station. And we can see that it decreases as the user equipment moves away from the small cell. And then we have further shown the cumulative distribution function, which just shows the average throughput in megabits per second for both 5G and for both 4G and 5G. And it can be noted that averagely 4G gives a throughput of around 210 megabits per second, and 5G gives us a throughput of around 280 or so megabits per second, which is more than the 4G, which is what we were trying to just show in our study. And then we further worked out the offloading in 5G and 4G. And then you can see from these two diagrams that we found out that offloading worked similar for both 5G and 4G. We can see that as the user equipment was closer to the small cells, you can see that offloading was the offloading worked out to be 67.11% of the user equipment when the user equipment were let me do that again. So the offloading was when the macro cell was so basically, when we're talking about the offloading, it is when we are comparing the number of user equipments, how they offload from the micro base cell and also the small base station. And we can see that at the edge of the macro base cell, we can see that there was 100% offloading capacity rate, and then when the user the macro base cell was closer to the small base cell, offloading was then shared into where the femto gave us about 33%, and then the macro, it was offloaded to 67%. And that is understandable why we had that. So basically, when we look at the results, they are similar for 5G and 4G. And in conclusion, I think from our study, it was shown that we can harness the power of using small cells to enhance connectivity and efficiency. And that can allow more researchers to explore other ways to enhance these supported throughputs and offloading rates that we have identified in our study. And thank you so much for listening and being part of this. I will then just wait for questions if there are any.
Hello, am I audible?
Yep.
Hello.
Yep.
Yes, sir, you are audible.
So, ma'am, can you tell me regarding you have said that you have used the Excel for the simulation purpose.
Yes.
So, can you tell me which are the libraries you have used in the Excel for the simulation purpose?
I didn't use any libraries. it was just a simple calculation where I loaded I loaded the Shannon theorem in Excel, and then I ran through the iterations, about 10,000 iterations in Excel, and I got results that I tried to show
So
in my.
have you collected this data?
This data we used the given, remember I said we used the given, oh, okay, I'm sorry. Oh, okay, so we loaded the Shannon theorem into Excel, and then some of the inputs that we used there were the adoptions that we get from the specifications that we adopted from ITU and 3GPP and 3GPP. And then we ran about 10,000 iterations of that.
Okay, but actually my question is, how you have got this data? Because this data is not available in 3GPP as per my opinion. That is what I feel. Because this is even my research area, so I'm using actually, so I will suggest you that you go for Qualnet or some other simulation software, so that your results will be more accurate, and I can say more powerful for as compared to the this things. That is only the suggestion from my side. Thank you.
Okay, thank you to Dr. Popat. We will consider that. And just to add a notation is that some of these were just random. We used random functions to pick up the distances, and it ran. Thank you so much for your input. Any other question?
Yeah, I was going to ask you about the results you presented, because the key doesn't seem to be very clear. In some of the graphs, you were having about 4 colors, 5 colors. I wanted to get
Okay.
clarity on which one is for which, like this one, this one, this one, this one. And if you come here, you have at least all the 4 colors. So what are the representations of these colors? Because it looks like it's so tiny for one to see. Okay.
Okay.
Okay, the other one is offload. Okay. Okay. So TH1 5G, TH2 5G, TH1 4G, TH2 4G.
Okay. So TH1 is the throughput when the small cell is closer to the microcell base station. So basically that is throughput 1. And then throughput 2, we were calculating the throughput when the interval between the macro base cell station and the small cell base station were 450 meters apart. Okay. And this, we then did the same for 4G and then 5G. That's why we are having 2 iterations in each.
Okay.
Yes, so the first 2 are for 5G and the second 2 are for 4G. So when the distance is 0.3 meters, then all the way up.
All right.
Is there any, should I show you the other?
No, it's okay. It's okay. It's all right. It was not clear to me when you were
presenting. Okay, thank you so much. Any further question?
Okay, we can go to the next presenter. Thank
Thank
you.
you so much, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next presenter for today's session is Kenya sir. Uh, I request Kenya sir, if you're present in the meet, to please start the presentation.
Oh, hello. So please skip this presentation to the full presentation. Can
Okay,
you
so
understand?
you want to present right now?
Yeah. So I because this presentation will I will assist. So because now I already present in IE room.
Okay.
So to change for skip. Thank you.
So the next, which one you want to present?
Bingo.
Okay, so we'll proceed to the next presentation. No worries. So you can start with the presentation, ma'am.
Sure.
Okay.
Can you see my screen?
Yes.
Yes, we can see your screen.
Okay. So, hi everyone. My name is Asha Taneji. I'm a researcher at Khalifa University in the United Arab Emirates, specifically at EPTIC Research Center. I would like to present our work, which is about human activity recognition via artificial intelligence on the edge. These are the points that I'll be discussing today. So first, we're discussing the aim of the paper. Then I'll go through the overall framework of the human activity recognition system. After that, I'll discuss the main components of any machine learning, which is the data acquisition, then data pre-processing and model training. The last 2 points will be the results and analysis, followed by conclusion and future work. So this work has 2 main purposes. First, we wanted to create a lightweight human activity recognition framework that can be deployed on a microcontroller. So we focused on having a lightweight model. The second aim is we wanted to compare the performance of 2 models using 2 input techniques. One is the raw input data. The second one is the model trained on a statistical feature. So let me quickly go through the framework of the full system. So the full system consists of 3 main blocks. The first block is a machine learning, which is the block that we use to design a machine learning model. It consists of data acquisition, data pre-processing, and model training. And the second block is a tiny machine learning. Here, the aim is to convert the machine learning model into a lightweight model that can be deployed on a microcontroller. And the main step is to get to the TensorFlow model, convert it into a TensorFlow Lite model, and then convert it to a C-wide array. And that can be done with the TensorFlow Lite libraries. The second block is the embedded system block. And this handles the deployment of the TensorFlow Lite model in the small and low-powered microcontroller and run inferences continuously to classify the real-time sensor data into the activity classes. So here basically we read the sensor data and we run inferences, and we classify them into the classes that we have. Okay, here let me discuss with you the data acquisition. So as we know, for any machine learning model, the data is the main ingredient here. And for this type of work, we used IMU sensors, especially sensors embedded in the Nano 33 board, the Arduino board. And the target has the sensor placed in the right pocket of the right trouser, where we collected the IMU sensor data for 4 human activities. And this work focuses on classifying 4 human activities. The activities are exercise activities such as jumping at a fixed position, right knee kicking up, squat, and walking at a normal speed. Just to give you an idea of the type of data we get, this illustration shows the acceleration data and the gyroscope data acquired for the squat class. And we can clearly see here that there is a clear pattern and there is a periodic behavior, which is very expected of this activity. Next is the data pre-processing. So we cannot use the raw data directly and feed them to the machine learning model. We need to apply some sort of pre-processing. For this work, we've applied the segmentation. So we took the raw data and we segmented into equal length windows, and each window is a 2 second of data. And this is done for all the data. The second pre-processing technique, we used it to compare it with the raw data, which is a statistical feature. So we got all the data and we computed statistical features for them. Mainly, we focused on the mean, standard deviation, kurtosis, and skewness. And later on, we'll show you the comparison between the raw data and the statistical features. But just to give you an idea, so here we are using 6 features, acceleration in 3 direction and gyroscope in 3 direction. And the window size is 2 seconds. And we also created an overlapping of 90% between the samples just to expand the data set. And the frequency rate here is 104 Hertz. This is a standard frequency rate for the nanoboard. Okay, for the model training, as I mentioned in the introduction, that our main purpose here is to have a model that is very small in size and that can be easily deployed on a microcontroller. So we decided to use a standard neural network, and we found that having the neural network with 4 layers was very sufficient, and we could we achieved a high accuracy with it. And the 4 layers has 128, 64, 16, and 8 neurons, and of course an output layer for the output needs. Now I would like to discuss the training performance. So we using this model, we have created actually 2 scenarios. One where the input is raw data, and second where the input is the statistical features of mean, standard deviation, kurtosis, and skewness. And here I'll show you the training performance of the 2 models. So this is the training loss, and here is the training accuracy. And I think it's clear to you that the model trained on a statistical input has a slightly higher accuracy than the model trained on the raw input. And we can see the model also, the orange line here, is converging faster than the raw input. This is because when we try to compute the statistical feature, we're actually reducing the dimensionality of the data, and we get less complexity compared when we use the raw input. And also, we filter out unwanted noise with the with the statistical feature, because we focus on meaningful data rather than just injecting the raw data to the model. Here's a snapshot of the deployment. So after we have deployed the model on the microcontroller, we can get the status or the probability of activities being performed. And this is what we get with the AI on the edge. And why we decided to go with AI in the edge, because it has faster running time and less computational power than other than the deploying it on the PC or on the cloud. So we decided to go with this approach. And here is the experimental result. So this is the performance of the two models trained on the raw data and on the statistical features. So it's clear here that when we use the statistical features as an input, we can see an improvement of the performance. So we get 99.2 accuracy compared to 89.5 accuracy when trained on the raw data. And those two are the confusion matrices. So we get almost a perfect result when we use statistical feature compared to the raw data. Here's another experiment that we performed. So basically, we performed the same 4 activities 8 times, and we are reporting here the probability of each of the activities for 8 rounds, and you can see here that we get a very high accuracy even if we repeat it. So this is the average accuracy for the 8 rounds. So we still managed to get a high accuracy for like multiple times. And here are the results for the knee-up class. So in conclusion, I just want to emphasize on that human activity recognition is a very exciting research area. It can be used for many applications in healthcare, security, and smart home. And this paper provided a complete framework for AI on the edge. And we use AI on the edge because of many benefits, such as the fast processing and lower computational. And we also tested two inputs, the raw versus the statistical features. And although both models, they have reported a good accuracy, but with the statistical feature, we can see that the accuracy is higher. So for future work, we are planning to train more human activity classes. Rather than using 4, we will use more, and we will integrate also different sensors. Another interesting area to discover here or to explore here is if we want to test different machine learning models, and we want to see their limitations and their performances when deployed on a device, because deploying a model on a device is very challenging and requires a special crafting of the size and of the pre-processing. And thank you. If you have any questions?
Yeah, that is interesting. But I'm just wondering why the statistical data appears to be of better performance than the raw data you have.
Yeah, that's a good question. Actually, with the statistical data, we get a less or a low dimensionality of the data compared to the raw input. So for the raw input, we need to inject the full 2 seconds directly to the model. But when we do statistical features, so we're kind of reducing the dimensionality. We are using only 6 features, which are the mean standard deviation, kurtosis, and skewness. And they provide like meaningful information, more like easier for the model to learn compared to the raw data. So that could be one of the reasons.
All right.
Hello.
Yes.
Ma'am, can you go back to your calculative data if possible?
Which one?
Yeah, this one.
Yeah.
Can you tell me why you have selected only these four activities like jump, knee up, squat, and walk? Or you have taken up from some literature review, or as you are showing only the knee up results? Is there any
Yeah.
specific reason for the same?
Yeah. I use these classes basically because we were thinking about focusing on the exercises being performed in a gym. So basically, like simple like exercises that's done in the gym, like a jump, knee up, squat, and so that can be expanded, in the future for um, like gym classes or stuff that can be used by instructors in the gym to detect the type of movement the trainees are performing.
So
Um, yeah,
can you tell me that it is like you are putting it as a your future scope of the paper?
not necessarily, but that could be one area we can like further expand. Like we can decide whatever activity we want, but for gym there are certain activities that are being done, and we can design like a specific app for that, or for people like some people will be interested more in healthcare applications, so they will go different type of activities.
Okay, that's great. Thank you.
Thank you so much, ma'am, for your presentation. Now, next, we'll go with the original order. Kenya, sir, you will be presenting next. So the paper title for Kenya sir's presentation is Enhancing Network Type Thinking in Early Childhood, a topic model approach to picture book analysis based on UD informatics. Sir, are you present in the meet?
Share the
Let us.
video now. I try. So could you give me the sharing?
What do you want?
Sharing means the so you share the your slide. So
Oh, I should stop sharing the picture.
yeah,
Okay.
thank you.
You can share now, sir.
Thank you, Chair. Good morning. Hello. Good evening, everyone. I'm Ken Abanaka, and I belong to Kobe Tokiwa University in Japan. Today's title is Enhancing Network Type Thinking in Early Childhood, a topic model approach to picture book analysis based on eduinformatics. This work collaborates with these members. The slide shows the recent key terms in higher education. ICT education is important for the younger generations because of the rapid evolution in technologies. COVID-19 restricted our lifestyle and strongly promoted learning methods from physical to online by ICT. STEAM education is one of the most important scientific literacy for younger generations in the 21st century. Moreover, both art and STEM created a variant discipline referred to as STEAM that assists in improving creativity for the younger generation. This means that STEM or STEAM education is important for not only higher education but also pre-primary education, primary education, and secondary education. Why do we have to think about STEM or STEAM education for the young generation? The answer is creative development for the younger generation, as well as improved quality of life, QOL, for their future. In the future, younger generations will have to use more ICT technology that is constantly evolving. Actually, this paradigm shift promotes the new era of Industrial 5.0 and Society 5.0. This slide shows the Society 5.0. Society 5.0 is a concept for a future society. The Japanese Cabinet Office defines Society 5.0 as follows. It refers to Society 1.0 as the hunting society, Society 2.0 as the agricultural society, Society 3.0 as the industrial society, Society 4.0 as the information society, and Society 5.0 is the future, new society. In the era of Society 5.0, education is not the same as Society 1.0 to 4.0. For example, the OECD has proposed competency-based education. Distinguish between technical and core competencies. The OECD defines core competencies as delivery related cluster, interpersonal cluster, and strategic cluster. Therefore, education in the 21st century includes both simple knowledge, the use of knowledge, and how to create new knowledge. Recently, we proposed new field eduinformatics. Eduinformatics is the word combination between education and informatics. This figure shows the concept of eduinformatics. The field of education provides problems to be solved to eduinformatics. The field of informatics provides problem-solving methods to eduinformatics. In this study, we explore systemic thinking as defined by the OECD's Education 2030 project, viewing knowledge as separate facts and connected network. We've previously described how knowledge evolves in three stages: gathering, combining, and creating new insights. Our research introduced to model that shows how individual pieces of knowledge link up in our minds to form a complex web. We also discuss the role of tags in connecting these knowledge pieces, making, navigating, and expanding our understanding easier. This approach helps us grasp complex concepts more effectively. In our study, we look at how using picture books can help young kids think in a connected way, as suggested by the OECD's Education 2030 project. We are trying to show that learning isn't just about knowing facts, but seeing how everything links together. Using computers and new tech, we digitize books and see how they connect, making learning more fun and broad for kids. This way, we are preparing them with the thinking and creative skills they need in the future, following what's needed in education worldwide. Before, analyzing text meant a lot of manual work, which took ages, and sometimes you couldn't even get the same result twice. Professor Baker even said most researchers struggle to repeat this on experiments. With new tech, we've got better ways to dig through text, like using computer tools to spot patterns and links between words. But it's not perfect. When there is too much data, things get messy and hard to understand. So we tried a different method using Python and some smart software to sort through 303 books, aiming to make sense of it all by focusing on 6 main themes. This way, we are trying to make learning through these books more connected and insightful. In our study, we used LDA to figure out how words group together in picture books. But sometimes words have more than one meaning, which can make things tricky. We sorted the topics into 6 categories, like animal-related and family-related. When we looked at how these topics relate to each other using a method called multi-dimensional scaling, or MDS, we saw interesting patterns. This method doesn't give meanings to the axes it used. It just shows relations between topics. This helps us understanding the complex themes in picture books and how they can help kids develop a networked way of thinking by showing them different aspects of life and ideas. This is conclusion. acknowledgement. This research was conducted based on the research grant for child education provided by the Hakuhodo Foundation. Thank you for your attention. Do you have any question?
Okay, I just have a comment. It's a good work. And I would like to say that that is the way education of the future is actually going, because at the moment, John Wiley, they have got, books for higher education tailored this way. The learning of the future is actually going towards the direction, because we have got Wiley's books, which are digitized with content and in such a way that the learner at his own is learning, and at the same time is thinking about what is being learned at the same time through some animations incorporated in the learning process, with participation activities, such that you don't just teach theoretically, you teach and you animate what you are teaching, and the learner at his own pace is able to participate in the activity by just touching on those simulated stuff in the form of pictures that actually portray what is being learned. So even higher education books by the Wiley through the Azai books is tailored this way.
Thank you.
I would like to give you, I can say, you have taken a new topic altogether which is helpful to the society, I can say, and which will be, I can say, more in the future task that will help to the society. So I would like to congratulate you for selecting this kind of topic for this conference. Thank you.
Yeah. Next presenter, please, if we do have it.
Thank you so much, Kenny sir, for your presentation. Now next presenter would be Sayaka ma'am. Are you present in the meet?
Yes, I assist her presentation.
Okay.
Can you give me the screen sharing?
Yes.
Hello everyone, my name is Sayaka Matsumoto. I belong to Tokyo Institute of Technology. Today, I'd like to talk about new methods and applications for visualizing web survey responses. We named those TechQuiz. Our collaborators are these members. The outline of this presentation is as shown. Information and Communication Technology (ICT) has made conducting surveys easier. Web-based surveys are frequently used in higher education institutions to gather information from students. Survey participant response behavior can often be problematic, such as forgetting to answer or giving up on answering in the middle of the survey. These behaviors can result in missing data and unfavorable impact on the survey results and quality. There are several reasons why data may be missing from a survey. The survey contains too many questions, which may decrease participants' motivation to take part. Some participants choose not to answer certain questions. This may be because they didn't want to answer or because they didn't understand the intent of the question. When we tabulate and analyze questionnaires, we analyze 1. Whether or not each participant has answered each question, and 2. The number of responses received for each question. These diagrams help us to explain the problems with the survey and also allow us to improve the questionnaire. We have named this procedure the System Technology Enhanced Quality Improvement in Surveys (TEQUIS) and are now presenting and discussing it. We first created a dummy dataset of 100 participants and 100 questions. The dataset consisted of 0 or 1. We defined 0 as if the participant did not answer the question, and 1 as if the participant answered the question. The dataset also has a gradual decrease in the percentage of 1 for each question. This is the future of the surveys that had too many questions, frequent missing data, or dropouts. This dummy questionnaire data was assumed not to have a required response setting, to have 91 multiple-choice questions and 9 free answer questions, and to contain 2 question groups for only specific participants. The first TEQUIS visualization heatmap style is a matrix with 100 participants and 100 questions, with cells color-coded red for 1 and blue for 0. The second TEQUIS visualization is a bar graph of the number of responses per question, and the line graph was superimposed on the bar graph by adding up the number of people answering at last the question. Finally, we observed both visualizations 1 and 2, listed the problems with the questionnaire estimated from those figures, and suggested ways to improve them. Figure 1 is the first TEQUIS visualization with heatmap style. 2 areas with many blue cells are limited respondent question groups. The number of responses decreases at the end of the questionnaire. Visualization 1 allows us to see the diverse response patterns of each participant and seems to be suitable for getting an overall picture of the response state. Figure 2 is the second text visualization with bar chart style. 80% of the participants responded to the initial questions, while 50% answered the final questions. Two groups of questions, which were targeted to some of participants, were answered by 10 to 20% of the participants. However, question 30 was answered by about 80% of the participants, suggesting that it could have been answered even by those who were not eligible. Visualization 2 allows us to determine the specific number of responses and to identify which questions triggered the respondents to finish answering and drop out. We observed two visualizations and summarized the characteristics, problems, and improvement plans for the dummy survey data as shown in Table 1. The survey responses decreased from 80% in the beginning to 50% in the end, indicating a decline in participation. This questionnaire should not contain more than 50 to 60 questions as it currently has too many. This questionnaire included two groups of questions that were targeted to some participants twice. The first question group had a characteristic that question 30 may have been answered by those who were not the target. In a group of questions targeting a subset of the population, indicate who is eligible and which questions may be skipped if ineligible. Questionnaires are used by institutions of higher education to collect student information. Not all individuals will respond to a distributed questionnaire, and some may choose not to answer certain questions. Text revealed the existence of questions that were difficult for participants to answer, and then the appropriate number of questions in a survey. Text makes it possible to improve the survey itself. A list of very useful recommendations to consider when designing a survey. For example, construct concise questions or ensure that the time required to complete the survey doesn't exceed 10 minutes. These were consistent with our suggestions. If some questions received fewer responses than others, it can be assumed that this was due to the survey design. Furthermore, missing data can occur for various reasons in any question. It is effective to check the distribution of missing data to maintain and improve the quality of the survey and its results. TechQuiz allows for the visualization of missing data, which can help infer aspects of participants' response behavior, detect problems with questionnaire design, and suggest improvements. This work was supported by this grant. References are as shown. Thank you for your attention. Do you have any questions?
Hi, Sayaka. Our presenter, are you there? Can you hear me?
Yes, yes, I'm here.
Okay, you are here. I have two small questions, very flimsy questions. Number one, were you presenting live or you were using AI tool? Number two, can you hear me?
Yes.
Okay. Number two is the work is a good work, but I would, apart from analyzing questionnaires and so on, can you consider taking this work to grade assessments in a learning environment where you will use this tool, this TechQuiz, to be able to analyze grade assessments of texts, okay? Assessment based on texts, okay? You give a text and students have to read it to be able to you assess students based on that. And then assessments that are straightforward assessment like multiple choice, you give them assignments and students are able to do that. Did you think you get what I'm saying?
Thank you
Can I
for.
help? Go ahead. Can I help her?
Yes, you can help.
Yeah. Shortly one more again. So her so main thing is new visualization for the answer of the questioner. But so in Japan, in our usually the the number of the questionnaire is very big, huge, more than
Okay.
100 questions. So the student give up to answering. So we can detect these these types of the questionnaire is bad. So the new visualization is TQS is very useful to detect these the student. So usually we have the hypothesis. What hypothesis? The student can answer all questions. Usually, we believe, but in this case, we find out that many students cannot answer the whole questions, give up because of the questionnaires. The number of the questionnaire is very huge, more than 100.
How about taking this study to grade assessments where you have to grade texts? You give students texts to read and you know, and then you give another assignment that is not text-based. You just score, you get the answer. Then how about taking the kind of study to text-based assessments?
Yeah.
And
So,
using this method.
Yeah,
Mhm.
in this case, the questionnaire is performed in a website using a
Okay.
Google form or something. So, but it is difficult to. So she said that usually the time of the answer is less than 10 minutes. Our presentation is about 10 minutes. I think the concentration of the human is not long. So we 10 minutes is the limit to the answer student. So we next we reduce the number of the questionnaire in the future.
Okay.
Mm.
All right.
Hello. Hello.
Yes, yes, yes.
Yes. Can you throw some light that how this research work is useful and to whom it is useful?
So in this case, our universities now there are 9 whole student questionnaires.
Okay.
So we together these types of the questionnaire. Usually the department of the perform the questionnaire is different department. So the each department cannot know the other questionnaires. So we combine the questionnaires and we control the question and reduce the number of the number of questionnaire. We will try. So in this case, this technique that TQS is very useful.
So don't you think that if you reduce the number of questions in the questionnaire, will it affect your quality of the what the data you need?
Pardon, one again?
See, as you are saying that you are reducing the number of questions in a questionnaire with the help of this research. So don't you think that if you reduce the number of questions in a questionnaire, it will reduce the quality of the answers also? Or
Yeah.
whatever the data you want to collect? So that
Uh,
parameter you should consider while making the research. Is it so?
so you said you mean that it's like a scale. So the we can reduce the number of
No.
in the mathematical.
What I'm asking is, say for example, you are preparing a questionnaire in which around 100 questions are there. Now, as far as your research is concerned, you are saying that if I'll ask this many questions, I'll not get the proper answer, or I'll not get the number of right answers, or so on and so forth. But if you reduce it from 100 to 50, don't you think that your quality or your whatever the data you are requesting will be proper, or will it be okay? If you can throw some light
I
on
think
this.
the quality is good because in this case, in my case, these data did the people means faculty or staff in the university did not use the result of the questionnaire at all. For example, the university reform or some things. So they simply get the answer. Can you understand? So they don't use the result to the university reform and so on. Just get the result.
Okay, fine, thank you.
Finish. So can I go to the next speaker? Next speaker is me.
Okay.
Okay.
You are having two papers.
Yes, sir, you're the next speaker. I just wanted to give a gentle reminder that we are running out of time actually. So
Okay.
can we just like wrap it up quickly.
Yes, ma'am.
I want to inform to all the participants actually.
Thank you, Chairman. Good morning, or hello, or good evening. I'm Kunihiko Takamatsu, and I belong to Tokyo Institute of Technology in Japan. Today's my title is Novel QR Code-Based Hybrid Knowledge Graph Node QR Node System, Transforming Higher Education with the Knowledge Network Tag Model and LMS based on AI informatics. My collaborators are Ikuhiro Noda, Kobe Tokiwa University, Tomoyuki Sakai, K Advance, Yasuhiro Kozaki, Osaka Kyoiku University, Kenya Bannaka, Kobe Tokiwa University, Sayaka Matsumoto, Tokyo Institute of Technology, Ryosuke Kozaki, International Pacific University, Akira Ito, Kobe Tokiwa University, Tetsuhiro Gozu, Kobe Tokiwa University, and Yasuo Nakata, Kobe Tokiwa University.
This slide shows the recent key terms in higher education: ICT, EBE, IR, LA, and DX. In the life science field, the International Human Genome Sequencing Consortium reported initial sequencing and analysis of the human genome in 2001 and finishing the eulomatic sequence of the human genome in 2004. The research involved various research methods since the human genome is about 3 billion base pairs. This means big data. Before human genome sequencing research, researchers only used phenotype research by experiments, referred it to hypothesis-driven research in life sciences. These figures show hypothesis-driven approach and data-driven approach. Hypothesis-driven methods involve the development of the hypothesis, and researchers perform experiments to confirm the hypothesis or not. If hypothesis is not confirmed, then researchers construct a new hypothesis and development a new experiment, and the cycle continues. Researchers had data on human genome sequence once the human genome sequence was established, which was completely opposite to the decision before. When researchers use a human genome sequence to construct hypotheses, it is called data-driven research. The hypothesis-driven approach and data-driven approach may look like two completely different methods. However, they are not. The hypothesis-driven approach develops new hypotheses based on data from experiments. Thus, hypothesis-driven approach is not easily separated from the data-driven approach. Moreover, hypothesis-driven approach and data-driven approach have a circular relationship. The situation described in the life science is also the same situation in the field of education. ICT education is important to the younger generation because of rapidly evolving technology. There have been recent international conferences and congress about ICT, one of them being this conference. However, COVID-19 has restricted our lifestyle and transferred learning methods from physical to online, forcibly changing our learning methods. LMS is very useful when students study something online. Data increase with online learning than before COVID-19. This situation is very similar to the example discussed regarding the human genome sequencing 20 years ago. That is to say, the big data era in the education field is now. Therefore, data-driven education is in existence or will soon come. I think many people know the field of bioinformatics. Bioinformatics is the word or field combination between biology and informatics. To quicken this research, we propose the concept of eduinformatics, a novel field of education that combines both education and informatics. In 2018, the term is a portmanteau of education and informatics. This figure shows the concept of eduinformatics. The field of education provides problems to be solved to eduinformatics. Eduinformatics deals with students' data and provides novel analytical methods and concepts for using data in education, similar to bioinformatics. This figure illustrates the relationship between ICT and eduinformatics and their combined impact on sustainable educational development. Eduinformatics underpins the integration of ICT in higher education, fostering digital transformation and enhancing institutional research. It provides a framework for covering technology in education, thereby improving educational practices and outcomes. This figure shows the concept of knowledge network graph models, illustrating potential feature enhancement for the QR system. It emphasizes the importance of these models in evolving educational technologies and outlines future research opportunity in informatics. As we explore these directions, we pave the way of future advancements in educational innovation. This figure outlines the QR system schema, a hybrid learning tool that bridges the gap between analog and digital learning through the use of QR code. The QR system enables a seamless learning experience by allowing students to transform their handwritten note into digital knowledge graphs. It represents a significant step forward in making learning more interactive and integrated. This figure shows an example for QR code embedded sheet distribution. These sheets blend analog and digital note-taking, enabling the transformation from handwritten note into digital knowledge graphs. QR code play a crucial role in this process, providing seamless access to digital resources and enriching the learning experience. This figure demonstrates classroom use of knowledge graph notes. These notes not only enhance student engagement and understanding, but also showcase the impact of integrating knowledge graph notes into various subjects. By visualizing information, students can better organize and retain knowledge, making learning more effective. The QR system offers substantial benefits for the educators by simplifying content management and grading. It leverages knowledge graph to access student understanding and provide targeted feedback.
This approach not only streamlines teaching process, but also enhance the quality of education. Conclusion. In conclusion, the QR system stands at the forefront of informatics, transforming education by seamless integrating analog and digital learning methods. Its impact extends beyond simplifying educational process, offering a more engaging and comprehensive learning experience. As we continue to push the boundaries of technology in education, we are not just adapting to the future, we are creating it. Acknowledgement. We would like to express my gratitude to the team behind the learning management system Manaba. Thank you for your attention. Do you have any questions?
Thank you for my presentation. Do you have any questions or comments? So anybody?
Yeah, because of our time.
Go ahead.
Because of the time, I think we can just
please
go
contact.
ahead. Any comments, we will send it through the chat so that we can meet up with time.
Thank you so much, sir, for considering the time limit. Now I request the next presenter to start the presentation. Ruxana ma'am. Thank you so much, ma'am.
Siddhi ma'am, I think this is the last one, no?
Yes, this is the last presentation for this session.
Thank you.
Okay.
A big hello and hi to everyone. I am Ruxana from Muscat College. Thank you for the opportunity. I would like to share my thoughts on our research that is an impact of co-innovation and big data analytics capabilities on organization resilience, evidence from Oman. We have three authors. It's me, Dr. Gopal Krishnan from Muscat College, and Mohammed Salman from PhD student from New Zealand, University of Auckland. Well, one second. Yeah. I would like to acknowledge to the research fund provided by Ministry of Higher Education, Research and Innovation in Oman. This is a part of funded project. So as we know, and we have experienced a lot of economic downturn, especially the recent pandemic, the advance in technology, especially during pandemic, the acceleration of technology used increased so much. And this has brought about a lot of turbines and uncertainties among businesses, especially the small enterprises. And even after post-pandemic, how business operators and organizations are just trying to adjust and operate to remain competitive is also very challenging. If you look from SME's point of view, the access to resources and financial constraints, shortage of skills, and so on is there for years. And these challenges are mitigated, and sometimes it becomes bigger where the SMEs do not survive. So looking into the advancement in technology and all this, we felt as a researcher that SMEs need to be encouraged to be resilient, to find a way in which they can adjust the business models based on new reality, reducing cost, or even to increase their customer base, especially through innovative strategies to sustain their market and to attract customers. If you look from the literature point of view, which we did a lot of intense literature, we found the biggest thing is from the dynamic perspective, researchers have commented and discussed that SMEs can have a greater chance of survival if they adopt some new novel technologies such as big data analytics. and they have to work on improving their capabilities in big data analytics. By this, what happens is the firm get competitive advantage, and at the same time, it will enable them to have a collective collaborative approach, which will lead to co-innovation. The co-innovation process, if you see, the collaborative and collective approach is very important. And for this, the technological platform plays a vital role, where the literature has shown that there is very little attention or limited attention in context of Oman in terms of technological platform for collaboration with SMEs based on innovative interaction model. So our objective of this study was to investigate the relation between big data analytical capabilities, co-innovation, and organizational resilience in a sample of SMEs in Oman. And this helped us to demonstrate how big data analytics and co-innovation are very crucial in building SMEs' resilience capability, and to explore how SMEs can pursue business continuity via big data analytical capabilities and co-innovation. Our hypothesis, we had 4 hypotheses. First 3 talks about interaction between the dependent variable, mediating variable, and independent variable. The last one was like analyzing the mediating role of co-innovation association between big data analytical capabilities and organization resilience in context of Oman SMEs. Our methodology, it's more like quantitative approach, and the sampling technique, we adopted snowballing sampling because this helped us to create a referral chain. And the questionnaire were designed based on the existing studies like Sing and all. And the measurement scale was like strongly agree to disagree. We had closed-end questions. And the statistical tool which was used to test the reliability of the data was Convash Alpha, the normal distribution kurtosis and squeeness. And we use SPSS software. And especially we incorporated Haynes process macro to test the mediating variable. And apart from the normal statistical analysis, like frequency descriptive statistics correlation, regression with bootstrapping was done. The key findings showed that 1 out of 150 questionnaires which we distributed through online through Google Form, we received 106 respondents for the survey. And we would like to thank the authority of SMEs in Oman to help us to circulate this to the entrepreneurs. And the response rate, if you see, was 150, so around 80 plus something. And out of this, 60% were male. They belong to age group between 20 to 29 is 50% of the respondent. And most of the firms were involved in service-oriented. So this is the basic structure of Oman. You can see is more of service-oriented industries and firms are available in Oman. So it is 87%. And most of the SMEs were situated in Muscat. And 58% of the firm size ranged between 1 to 9 employees. And 69% firm's age was less than 1 year, which means it just started after post-pandemic. The most important thing which we wanted to look into is the frequency of network, because we are talking about co-innovation. So definitely we need to know the frequency of network between the SMEs and their stakeholders. The respondents said that often they meet with their suppliers and other industries of the firm. Sometimes, or if needed, they meet their customers, investors, or universities and colleges. And rarely they had some connection with the incubators. To conduct the mediating analysis, regression, we went for multi-cardinality analysis, and we found that the correlation results of the data were less than 0.70. So this confirmed that there is no significant multi-cardinality with the data. So we went ahead with conducting the regression analysis and mediating analysis. And it was very impressive to see that definitely, as we hypothesized, that the co-innovation definitely mitigates between the big data analytical capabilities and organizational resilience. So all the hypotheses which we set were accepted because of the significant level, that is 0.00. And the bootstrapping results also showed the direct and indirect effect had a significant impact. So definitely we can conclude by saying that co-innovation mitigation effect, co-innovation has a mitigation effect between big data analytical capabilities on the organizational resilience. Just to conclude, the results is similar to that of prior studies which were conducted in other part of the world, and we see there is a strong correlation between big data analytical capabilities and co-innovation. And the result also helped us to enhance our knowledge and sharing because of the data integration and analysis. This helped us to go further to go for our funded project about SMEs resilience. And one of the key aspect of the attribute which we found was related to big data analytical capabilities. Definitely, the results will help the SMEs to know how innovativeness and getting connected with the their stakeholders are very important, because this will definitely improve their business process and enable their dynamic capabilities to gain competitive advantage and sustain in the market. So we can therefore say that the co-innovation is a very important process which will help definitely to reduce the cost, risk, and increase the ability to observe the knowledge. There is a suggested, we suggest that we need to include more response from different sectors, and more people we need to extend, because this study was just for 4 months, and the respondents were only from Muscat majority, and there is another governance and region like Musandam, Dhofar and all that. So we need to collect more data from there so that we can get more accurate result, and we can come to a generalized conclusion which can be applicable to the majority of the SMEs in Oman. And with the fast growing technological development, management of big data can be one of the limitations for SMEs. That was also one of the findings which we thought we need to put into it. And so we provide a suggestion that SMEs can start looking for adoption of big data analytics into their businesses, so that they can improvise their skills and infrastructure. So there is a recommendation and suggestion made for the policymakers to provide support. And in Oman, there are a lot of support that is coming from the government, especially for development of entrepreneurship. And this study will definitely help them to get an insight on the usefulness or the importance of big data analytics and co-innovativeness. And one more thing which suggests was we can compare between developing countries and developed countries by taking some data. So that will be our next phase of analysis, and we can also include other industries, also compare between SMEs and other big firms. So these are few references. Thank you. If you have any question, please do let me know.
Thank you. I just have a comment.
Yes, sir. Yes, doctor.
Yeah, it's a good study. However, the sampling technique of snowballing,
yes,
represented as a quantitative method, is not usually the case, for the fact that the sample you collect does not usually represent it's not usually representative of the entire population. So usually what is done is it's better applied as a qualitative study.
Okay,
You
sure,
can take up
definitely.
that yourself, yes.
Yeah.
So it's not that you cannot collect quantitative, qualitative data for a snowball study, but the fact is that because the sample is not usually representative of the population you are targeting. So
yeah,
that's why you apply it in a qualitative sense, not quantitative. That's just a
okay.
comment.
Thank you for the suggestion.
Okay.
Yeah, definitely.
Thank you so much, ma'am, for your
Ma'am,
presentation.
only one suggestion from my side also that as you all.
Hello.
Yeah.
I think Dr. Kaplesh.
Okay, ma'am, only one suggestion, as you have already mentioned in your presentation also, that you should increase the size of the data
Yeah,
which
sample
you
size.
have. Yeah, sample size should be increased, because otherwise the results which you are getting is not significant, I can say.
That's
Yeah.
exactly
Because
what
only.
I'm saying. So that's exactly what I have told her.
Yes.
Because
yes, I agree
snowballing
with.
is very small sample. You can't use it to represent the target
The
population.
actual data, yes. The actual
Yes.
results may not be the same one with the this much data and with the actual big data, or we can say with the big size of data.
Yeah, and you can't be talking about big data with snowball.
Very
Okay.
true,
Yeah,
sir.
definitely. Yeah. I understand what you're saying, but this
Yeah,
is like just for 4 months, maybe
it's like a
inshallah.
pilot for you.
Yeah, it's like a pilot study. Yeah.
Okay.
Thank you.
Thank you.
Thank you, ma'am. Now I'll just give my closing remarks and end the session. I sincerely thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of the International Conference. I hope this session was informative enough. On behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates via email within 2 working days. Further, all the papers have been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Dr. Ezekiel sir and Dr. Kalpesh sir, for chairing the session. Let me just share my screen. A token of appreciation to the chair on behalf of Team ICCIT and Global Knowledge Research Foundation and partners. Thank you all for your valuable presence. Now, lastly, I kindly request all of the participants and chairs to turn on their videos so that I can take a quick snapshot of the conference. If you don't mind, please turn on your videos. Thank you.
Okay, thank you.
It was the next session, actually. This section took a while.
Okay. Thank you.
Kalpesh sir, can you please turn on your video? I didn't took the snapshot previously.
Yeah.
Thank you so much, everybody. Thank you for your valuable presence. Now I request everyone, you may end the meeting now. Thank you.
Thank
Thank you
you.
very
Thank
much.
you. Bye-bye.
Thank you.
Thank you very
Thank you.
much.
Bye.
Thank you.
Bye.